Omo 1 is considered the oldest anatomically modern human ever discovered, but just how old is she really?
There were people who were saying, this stuff's probably 20 or 30,000 years old. There was an old date that said it was perhaps as much as 100,000 years old.
In the dry, windswept gullies of the lower Omo Valley in Ethiopia, fragments of a skeleton once lay scattered across an eroded hillside. In 1967, members of the International Omo Research Expedition collected the bones and reassembled them into a skull and postcranial frame. What emerged was a face that could have belonged to any modern Omo Valley resident, high-domed, delicate, with a prominent jaw and a strikingly gracile face. They called her Omo 1, and for half a century she's been celebrated as the oldest Homo sapiens ever found. Yet from the beginning, her antiquity was less a fact than an aspiration. This statement isn't conjecture or speculation. These questions come from the statements made by geologists and scientists who were on the expedition in 1967 and later expeditions to the region. The skeleton may look like us, but its placement in the sediments of the Omo Valley has always been precarious, perched on eroded surfaces and entangled with much younger archaeological horizons. Recent attempts to push it back to more than 200,000 years only deepen the paradox, for Omo 1 is too modern to belong in that deep time. The truth may be that this fossil is not a Pleistocene ancestor at all, but a modern human, buried on a lakeshore after a violent death. The very words of Dr. Karl Butzer, the geologist who mapped the sediments in 1967, gave the first hints of trouble. Omo 1, he wrote, was resting upon the eroded surface. That phrase is deceptively simple. It means the skeleton was not sealed in a pristine layer of sediment, but lying on a surface already cut, churned and reworked. In geological terms, it was exposed, not entombed and not in situ. Butzer was careful, noting erosion across the site. The layers could not be read like the pages of a sealed book. Instead, they were scraped clean and written over by repeated floods and regressions of the Omo River Delta as it spilled into Lake Turkana over thousands of years. The first numerical age came not from soil, but from a single mollusk. Butzer collected a freshwater Etheria shell close to the hominin horizon. At the Lamont Geological Observatory in New York, it was assigned the laboratory code L1303J and returned a uranium series age of 130,000 years. However, Butzer hedged immediately, warning that mollusks are chemically open systems and that this date should not be taken too seriously as an age. Richard Leakey, by contrast, eager to place his Omo discoveries into the spotlight as the very origin of modern humanity, embraced the number as solid proof. For more than 3 decades, the 130,000-year figure appeared in books, magazine articles and museums as if it were bedrock. A single shell became the cornerstone of human evolution, and the basis for the Garden of Eden theory, which became known as the Out of Africa theory. The cracks in that foundation were obvious. Other mollusks from the Omo sediments returned ages of 5,000 to 10,000 years. No other shell matched the 130,000-year age. Nobody visited the site for over 30 years until volcanologists tried again, this time sampling pumice from a layer they called the Nakakaya Tuff, said to lie just below the Omo horizon. Argon-argon dating gave an age of 197,000 years. Finally, in 2022, Aurélien Vidal and colleagues analysed glass shards from the overlying KHS Tuff and matched them chemically to a colossal eruption of Shala volcano, dated to 233 plus or minus 22,000 years. Omo 1 must therefore be older than 233,000 years, they concluded, treating the tuff as a temporal ceiling that forced the fossil back into the Middle Pleistocene. But here the puzzle becomes untenable. Omo 1 is unquestionably modern in anatomy. The skull vault is tall and globular, the face reduced, the jaw delicate, and the chin pronounced. It is not an archaic Homo sapiens like Jebel Irhoud at 315,000 years or the robust Hertocrania at 160,000 years. Omo 1 looks like us and nothing like Neanderthals or transitional populations. If it truly dated to at least 233,000 years ago, and possibly 255,000 years ago, then we would be forced to imagine fully modern humans walking the floodplains of Ethiopia 200 millennia before the Holocene. Yet no other fossil, no genetic evidence, and no archaeological record support such a vision. As Saal and colleagues noted in a 2018 review, most of these sites have considerable age uncertainty, and Omo 1 is precisely the sort of fossil whose stratigraphy leaves room for doubt. The most parsimonious conclusion is not that Omo 1 is an anomaly of deep time, but that it is out of place, a modern skeleton intrusive into older deposits. The local archaeology reinforces this view. The very site where Omo 1 was discovered is also called Harpoon Hill, for the barbed bone harpoons and fish remains found scattered across the surface. These artifacts have been securely radiocarbon dated to around 9,900 years ago during a Holocene high stand of Lake Turkana. Butzer noted them himself, acknowledging that late Stone Age people had camped along the same eroded banks. The idea that a human burial might have been dug into older sediments and later exposed is not far-fetched. The Omo Delta has been a burial ground for millennia. This explains why the skeleton was resting upon, rather than sealed within the sediments, and why its anatomy is so modern. The minimum age derived from the eruption 233,000 years ago may apply to the sediments, but not to Omo 1 herself. The fossil is younger than the ash, not because it is older, but because it was never part of that stratigraphic story in the first place. There are signs in the bones themselves that suggest a more recent fate. The leg fragments bear crushing marks that some researchers have likened to bite damage. In the swampy delta margins of Lake Turkana, crocodiles and alligators have long been apex predators. An attack in shallow water, followed by a body washed into the shoreline, would account for the fractured leg bones. Such a scenario fits better with a Holocene lake high stand than with a middle Pleistocene volcanic landscape. After the attack, the body could have been buried rapidly in lacustrine silts, only to erode out thousands of years later. This interpretation dovetails with the harpoons, the fish bones, and the cultural debris that litter the same surface, which include the skeleton of a pelican and wild cattle. The postcranial skeleton adds its own ambiguities. Among the fragments is a pelvis that has confounded anthropologists for decades. The initial reconstruction treated it as male, with a narrow sciatic notch. Later studies, including a reanalysis by Dr. Natalie Hammond in 2017, questioned whether the curvature suggested female anatomy instead. The difference is crucial. If Omo 1 were male, then the skull must be compared to robust Homo sapiens males, and its modernity becomes striking. If female, then the cranial vault proportions seem even more gracile and contemporary. The only reconstruction of the skull was done in 1982 by the Leakey Foundation and the British Museum using a lump of blue clay. There is no modern 3D reconstruction, no brain cast, no analysis of the teeth, no digital reconstructions. The British Museum and Ethiopian Museum won't allow any new analysis of the skull fragments, but why? To this day they insist the skeleton is male and doubts the new date of at least 233,000 years, because this date makes no sense because anatomically modern humans were not walking the planet at least 233,000 years ago. Either way, the pelvis underscores that Omo 1 was not an archaic hominin at the dawn of Sapiens, but a fully modern person. Its sex may be disputed, but its morphology is not. This was someone who could walk the streets of Addis Ababa today without a second glance. The mismatch between bones and sediments has long left researchers uneasy. A 2005 study admitted that the stratigraphic relationship between this tuff and the hominin fossils remained uncertain. Vidal conceded in 2022 that the challenge remains to obtain a robust maximum age for Omo 1, and discoveries and dating calibrations of previously reported fossils require revisions. These words point to the same problem. The fossil and the soil are telling different stories. The soil may be 233,000 years old, but the skeleton cannot be. It must be younger, and the simplest explanation is that it was inserted into that soil by natural or human agency much later. Seen in this light, The legend of Omo 1 is not of the oldest modern human, but of a misplaced one. Imagine a Holocene hunter by the lake, stalked and struck by an alligator. The body, crushed and torn, drifts into the delta muds. A shallow burial is made in the silty bank. Millennia later, as the Omo River carves again through its deposits, the skeleton emerges onto an eroded surface, to be found by paleoanthropologists who mistake it for an ancestor. The irony is sharp. In seeking the deepest roots of our species, we may have uncovered a far more recent death. Omo 1 remains a symbol of the complexities of paleoanthropology, a reminder that fossils are not only bodies, but also sediments, surfaces and stories. The museum-goer gazing at the reconstructed skull in London sees a face that is unmistakably human. But behind that face is a geological riddle, one that resists tidy resolution. The volcanic tuffs tell of cataclysms 233,000 years ago, but the skeleton whispers of crocodile-haunted lakes just 10,000 years past. Science thrives on such tensions, where every bone is both evidence and question mark. The lesson of Omo 1 is not that we have found the oldest human, but that we have found the limits of certainty. Stratigraphy can mislead, dates can be championed or dismissed, and fossils can travel through time not only in evolutionary lineage, but in geological displacement. Omo 1 might never yield a definitive age. What it has yielded is that in the shifting landscapes of Ethiopia, even the most modern of humans can masquerade as ancient, and that the face of our species can look back at us from a burial not 233,000 years ago, but from the shores of a Holocene lake where harpoons and crocodiles marked the rhythm of life and death.
It's been really difficult to find it. It's taken us 4 hours to walk here, and we've been a circuitous route through the bush. And it seems really strange that there's nothing to mark it.
As discussed, Carl Butzer, the geologist from the University of Chicago, who was with the 1967 expedition, described Omo 1 as a surface find, suggesting it was exposed on the ground. Richard Leakey, however, labelled it partially in situ, implying some parts remained embedded while others were surface exposed. This fact is not a minor detail. It is of vital importance. In fact, the very foundation of that discovery, whether the fossil was found in situ, which means buried in its original context, or merely as a surface find, is shrouded in conflicting accounts. This is a perplexing case for Omo 1, the so-called earliest anatomically modern human skeleton. Meanwhile, another study from 2008, misleadingly titled Confirmation of a Late Middle Pleistocene Age for the Omo Kibish, One Cranium by Direct Uranium Series Dating, asserted that Omo 1 was found in situ, implying it was fully preserved in its stratigraphic layer. But this study did not confirm anything. In fact, they used the same dubious dating method to directly date the fossil as was used to date the shells. Another study by John Flegel, also in 2008, they noted that, according to the original description, excavation of the site yielded some material in situ and established the provenance of the Omo 1 skeleton in terms of the stratigraphy of the Kibish deposits. Both the cranial remains and the post-cranial remains have been considered by virtually all researchers to represent anatomically modern Homo sapiens. Flegel continues that, in the same year as the original description, papers describing the geology of the Kibish Formation and the hominid sites, including a series of radiometric dates, were published by Butzer and Thurber. They note that Leakey had received a test result of 130,000 years from a single shell, using thorium-uranium dating. In the paper, the authors noted that the accuracy of ages, calculated from thorium-uranium ratios, is difficult to determine, and perhaps impossible even with much more detailed work. The age reported here should not be considered too seriously as an age, they warned. In his 1969 report, Butzer wrote that the 130,000-year age came from a personal communication with Leakey. The lab number for Leakey's shell is noted as L1303J, which suggests the skull was dated at the Lamont Laboratory, where Thurber worked. Thus, It is interesting that Thurber apparently did not want that 130,000-year age to be credited to him, and he did not include the test with the results of the carbon-14 dating of the other shells. These doubts over the actual age of the Kibish fossils were echoed by subsequent reviews of the material for several decades. In a review of African hominids in 1978, Frank Howell, who was the co-leader of the 1967 expedition with Leakey, noted, "Human cranial remains, and some associated postcrania, were recovered from a situation considered to represent the lower part of the Kibish Formation in southwestern Ethiopia. This unit of the Kibish Formation was accumulated when Lake Turkana stood some 60 meters higher than its present level and flooded the whole of the lower Omo Valley around 10,000 years ago." Howells continued, "An age as old as 130,000 years has been suggested for the specimens on the basis of thorium-uranium measurements. Yet the reliability of this method has still to be adequately demonstrated. Even if this determination appears reasonable, it is nonetheless unconfirmed. The radiocarbon determinations on shells from overlying members with a minimum age 37,000 years have also been questioned. The mammal fauna associated with one of the specimens, with few species represented and none of them extinct, is frankly unhelpful and also unconvincing of any very remote antiquity." This is a stunning critique by a well-respected anthropologist who was a co-leader of the expedition. This trio of conflicting descriptions, surface find, partially in situ and fully in situ, creates a foundational problem for dating the fossil accurately. Why do these accounts conflict? And what does this mean for the reliability of Omo 1's age? The term partially in situ is particularly ambiguous. In archaeological terms, in situ means a find remains in its original depositional context, allowing geologists to date surrounding sediments or associated materials with confidence. A surface find, conversely, lacks this context, as erosion, water flow, or human activity could have moved it, rendering soil-based dating unreliable. Partially in situ suggests a hybrid state. Some elements of the skeleton might have been under the surface, while others lay exposed. But which parts of the skeleton? Without detailed documentation, it's impossible to determine. The original study notes the skeleton was found near the base of a small hill, with a step trench dug afterward, but it offers no clarity on what was truly embedded versus scattered. When archaeologists revisited the site 40 years after the 1967 discovery, they found more skeletal fragments laying on the surface, which this time they photographed. Compounding this mystery is the absence of photographs or detailed drawings of the original discovery, despite the expedition being well funded and professionally led, equipped with cameras and video technology. Why was such critical evidence not preserved? The lack of visual records leaves us questioning the integrity of the discovery process, a gap that undermines confidence in subsequent age estimates. The absence of photographic or detailed documentary evidence from 1967 is a glaring omission for a well-funded expedition. It was common practice by that time for fossil finds to be photographed in their original position for the very reason that it is very important information. Leakey's leadership and the presence of advanced equipment suggest this was no amateur effort, yet no images exist to settle the in-situ debate. A surface find would diminish its scientific value, forcing reliance on indirect dating methods prone to error. The partially in-situ claim by Leakey adds complexity. Did the skull remain embedded while the skeleton eroded out, or vice versa? Without specifics, we're left guessing, a frustrating gap for a find of such importance. As stated, Leakey obtained a single date of approximately 130,000 years for the Etheria reef mollusks, a figure he championed as fact for decades. Butzer cautioned that this date should not be considered too seriously as an age, due to open system behavior in mollusks, where uranium leaching distorts results. This methodological critique raises a red flag. If the date is unreliable, why did it become the accepted age for Omo 1? Thank you for watching and commenting.